Alright guys, how's it going? I thought I'd make a quick video real quick because I thought it'd be easier than typing out all of my thoughts. So this is chapter 1, question 25. A few of you have asked questions about it. So if we read the question, it says, the curved arrow notation is a powerful method used by organic chemists to show the movement of electrons not only in resonance structures, but also in chemical reactions. So that's our first big hint about what we're going to be doing. So up until now, we've been doing resonance structures, which is where you do not move atoms around. You only move electrons. And we've been using the arrows for resonance structures. So that's why I think this one gets a little bit confusing. But this one says right here, if I highlight, it says also in chemical reactions. So it says so we're going to be doing a chemical reaction, which means moving an electron. We will be creating a completely new molecule. It says, since each curved arrow shows the movement of two electrons, following the curved arrows illustrates the bonds that are broken and formed in the reaction. So we're going to be breaking a bond and forming it in this middle step. Consider the following reaction. Use the curved arrows drawn in the reaction to draw the structure of X. This is X. X is converted, and that doesn't matter. So basically, this is kind of easy. It's just introducing us to the concept of breaking bonds and moving them around. So this second one right here is what we call a hydride shift. You'll learn more about that in OChem 2. But then it also has two electrons here moving over. So we're literally just going to follow exactly what the arrows say. So if I get out my drawing pen here, I'm going to go ahead and do that. So first we'll start off just by drawing the benzene ring. Goes something like this. I'm not very good at drawing. So first we're going to move this hydrogen over. So it says right here that we're going to move this hydrogen over to this one. So we already had one right here. We're just going to add one right there. Boom. Okay, what about the other arrow? It says that we're moving two electrons down onto this bond to form a double bond. So we'll have our oxygen here. So we're moving two down to form this double bond. We have the H, it's an OH functional group, which is alcohol. So I'm just going to draw that like this. And then we have two more electrons left on the O. So 1 and 2. Boom. Now we're going to add the rest of this. So we didn't touch this bond at all, nor did we touch this one. So we'll just put those on back. Now let's double check that we have the octet fulfilled for every electron. Okay, we look at this C in the middle here. We've got 1, 2, 3, 4, 5, 6, 7, 8. That's octet. Okay, what about the carbon over here? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. We didn't touch any of the other bonds, so they should all be good. But remember that they have implicit hydrogens forming off of them. Oxygen, so we have 1, 2 forming to the H to form the functional group of alcohol. That's 1, 2. Then we have the double bond 3, 4, 5, 6. Then we have the the lone pair, which is 7 and 8. Done, right? No, there's one more thing we have to do, and the homework will not like if we have to do it. We have to calculate the formal charge on the electrons. So before, if you look over here at the original problem, our formal charge was located right here on this carbon, but we just added a hydrogen to it. So if it had a +1 charge and we added a hydrogen, which would bring in another electron, that would bring it back down to 0, right? And we can calculate that to double check. The formal charge equation is going to be formal charge equals valence electrons minus non-bonded pairs. Oh, I'm gonna run out of room. Minus bonded pairs over 2. That is the formal, these are parentheses, that is the formal charge equation. So if we run that off of the C here, we have formal charge of C equals valence electrons of C. We can get that from the periodic table we know as 5. 5 minus non-bonded pairs. This C has 0. Perfect. Minus bonded pairs, it has 1, 2, 3, 4, which there's always 2 electrons in each pair, so that's 8. 8 divided by 2. Oh, I'm sorry. It's carbon has 6, right? Yeah, carbon doesn't have 5. I'm going to open up the periodic table and double check. Carbon has 1, 2, 3, 4. No, it has 4. I'm all over the place. Okay, carbon has 4. 4 valence electrons. So let's erase this. Okay, so 4 minus 0, 0. 4 minus 8 divided by 2 is 4. So C has a formal charge of 0. Boom, we just proved it. Okay, so this charge has disappeared. What about the other one that we changed? The O. Let's do it for the O. Formal charge of oxygen equals valence electrons of oxygen. This one is 6, if I'm not mistaken. Let's open it up. 1, 2, 3, 4, 5, 6. Oxygen has 6 valence electrons. 6 valence electrons minus non-bonded pair. We have 1 here, 1 there. That is going to be 2, or 1, 2 electrons. 6 minus 2 minus the bonded pairs. It has 1 bond, 2 bond, 3 bonds. 1 double bond and 1 regular bond, which is going to be 6 electrons total. 6 over 2 is going to be 3. So oxygen equals 6 minus 2 is 4. Minus 6 divided by 2 is going to be 3. So oxygen has a formal charge of plus 1. So the last thing we need to do is we need to add a plus to this oxygen to indicate that it is positive, or it has a positive formal charge. And boom, there's your answer. So you can go ahead and submit this into the homework and it should work. Any questions, go ahead and just link them in the Discord and I'll see if I can answer them. Hope that made sense.